Okay, good morning. You're in the Working with Your Maps online and offline session for the ArGIS Runtime. I'm joined by Nick Furness from the Runtime team, and we're going to talk about working with maps online and offline. This is part one of a three-part workshop series. The second workshop is about editing data online and offline with the Runtime, and the third one is about optimizing your workflows online and offline. And the third one's new this year, and it has a lot of great content for people that are new to working with the Runtime, or people that have been building online, offline applications for a while. I think you'll really benefit from attending the third workshop. There's some really nice information there, and they cover from simple to quite advanced scenarios. So let's get started. When you're designing your application, you've really got to think about connectivity from the very start, because the connectivity of your users will dictate some of the functionality and how you work with the runtime. You've got to ask yourself these questions. Are my users always connected reliably? Are my users always disconnected? Are my users occasionally connected? And if they're occasionally connected, how is that connection made? Is it temporary interruptions that they don't really have much control over? Is it deliberate, I'm going offline tomorrow and I need to get my data on my device? That type of question is really important to get the answers, because as we go through the presentations, you'll get a feel for the various workflows that are supported. The good news is we have workflows and technology that supports all of these use cases, but you need to know which workflow to use to make sure your users have the best experience. Maps are fundamental to ArcGIS. They're fundamental to the runtime. And we like to really promote the use of maps. And when we're thinking about our online, offline scenarios, we are thinking in terms of maps a lot of the time. Because if you work with the map, a lot of the nitty-gritty details of how a particular service is taken offline, because you can have different layer types and they all behave slightly differently in how the data comes from the server to the client, all of that is taken care of for you by the runtime. Now, having said that, if you want to, you can work directly with individual services. There's nothing to stop you doing that. The API supports it. But a lot of the time, working with maps will greatly simplify your developer experience. But maps can contain operational layers with all the symbology and the pop-up definitions. They contain your base map layers. They contain some metadata about the map. So let's look at our first scenario. Always connected, an online web map. So here you're definitely working in a services pattern, similar to how the JavaScript API works with maps and layers. You're always requesting data from a server. You can edit it if the service supports it, and you've got to push these edits back through the service, and there's more details in the second workshop on doing that. These web maps can be authored in Pro, they can be authored in online, or you can author them in code using the runtime and the API. So let's take a look at a web map. So there is a web map portal item. It contains a little bit of metadata, the thumbnail, some permissions, sharing properties, and it points to the map document. This is if you like, the web map itself. And it's a fairly large JSON document, has a lot of information in there, depending on the layer types that are being pointed to by the map. But the map can have a tiled layer. It's backed by a tiled service. It can have feature layers. Feature layers are backed by feature services. A feature service can have multiple layers coming from it, and you can have any number of feature layers and connect into any number of feature services inside of your map. A feature layer can also connect to a feature layer item in your portal, ArGIS Enterprise or ArGIS Online. And this allows you to provide overrides on top of the feature service. So by default, a feature service advertises not just the pure data itself, the geometry and the attributes, it also advertises the symbology that should be used when that feature service is connected to. But with a feature layer item type, you can override that symbology. This allows you to support many specific use cases from a single feature service. It's very flexible. A vector tile layer connects to a vector tile service, and just like a feature layer, a vector tile layer can connect to a vector tile layer item, which allows you to override aspects of the vector tile service. This is exactly what we do to support all the different base maps that Esri provide. We've got many, many vector tile base maps. They're actually supported just by one or two vector tile services. And all the different symbology options are controlled by overriding the default vector tile service symbology and storing these overrides in the vector tile layer item that points to a specific set of resources. So to display a web map on a runtime application, first of all, you get a connection to your portal using the portal class. You then get the portal item specific to the web map. So that's using the item ID of the web map. And then with that portal item, you can instantiate a map. Once you've got the map, you bind it to the map view. And from that stage on, the map view takes care of everything else. So that was in a fully connected mode. Let's look at working in a disconnected mode, when you're always disconnected. This is a workflow where we utilize ArcGIS Pro to create packages. You can create mobile map packages and mobile scene packages with ArcGIS Pro. It's a read-only workflow, so it's a case of you're using Pro to create the content, create the packages. You're getting these packages loaded up on the device, either side-loading them onto device or using some other mechanism to download the packages initially onto the device. You can use ArcGIS Online to do that if you want. But typically, for the always disconnected, you're side-loading them using the appropriate technology depending on the device type. And it varies, for instance, if you're on a Windows device or an Android device or a iOS device, how you get files pushed to the device. And once you've done that, the runtime can open up the package, interrogate the package for the maps and the scenes that are contained within it, because packages can have multiple maps or multiple scenes, and it picks the map and binds to it and displays it. The API at that point is then very, very similar. For going offline with 3D, this is the only option to go offline in 3D. You can't currently take 3D content from a scene layer offline dynamically, and you can do that with mapping 2D content, and we'll see that later on in this presentation. Now, if you have a publisher extension, you have the flexibility of putting an expiration date into your package, and that way you can ensure your users don't use packages that are out of date. And the expiration process can present a message to the user to say, this package is out of date, and please go and request a new package from your system administrator, or whatever the message is that you want to put in, which is a nice thing. Transportation networks and locators are supported, so that means you can do routing on a network. You can even do navigating with voice guidance and automatic reroute on a transportation network contained within one of these packages. And locators support geocoding, reverse geocoding, etc. These packages are extremely easy to create once you've made your map or scene using ArcGIS Pro. So what's inside of a mobile map package? It's conceptually quite similar to a web map. We've got our item info, it has a little bit of metadata about the map, and then it points to the map itself. Maps can have tiled layers, they're backed by tile packages. They can have feature layers, they're backed by geodatabases. They can have feature layers with overrides, backed by geodatabases. A mobile geodatabase has all the symbology information required to render the feature class. But you can override that with these feature layer overrides. Here's a vector tile layer, which is backed by a vector tile package, and likewise, you can override a vector tile package's built-in symbology with a set of resources to give some custom rendering of the vector tile layer. So it's time for our first demonstration, and this is from Nick, and he's going to show us a demonstration of displaying maps from mobile map packages. Over to you, Nick.
So I want to take a quick look at generating mobile map packages. You can do that in Pro. You generate an MMPK file that you then have to sideload onto your device. Here I've got a Pro project that has a couple of maps in it. It's all looking at the same data, just different views in the same project. And if I just want to export the current map as an MMPK, I can pick the map, I'll go Share, and use the Mobile Map Package tool. This is now going to create, you see it says Share the Stormwater map, that's this map here, as a Mobile Map Package. It's going to create an MMPK of just this map. I'll give it a location, specify a little bit of stuff about what I want included in here, how I want to clip the data. Maybe I've got a polygon layer that will define an area of interest for me, and I can package that up. Clicking Package will generate an MMPK. But MMPKs are mobile map packages, so they can include more than one map. And let's say I wanted to create one that had both the overview and the stormwater map in it. Well, in that case, I go to the GP tool, and I look for the Create Mobile Map Package tool. You can search for it. It just happens to be in my history here. So I'm going to fire this up. And when it shows up, we'll have a few options. This is very similar to the other tool, only now we get the opportunity to select from a number of different map definitions that we have defined in our project. Still specify the MMPK location, and there's a little more information here. Since we've now got multiple maps in there, we can say I want to export the data covered by the union of those map areas. And then I'll just go ahead and run that. That generates one MMPK with multiple maps with just one set of data that all those maps make use of. So let's take a single map MMPK and look at what that looks like on an iPad. So here I've got Dropbox with an MMPK, and I've written a runtime application that knows how to open MMPKs. I'm going to tell Dropbox to just open it in that application. And that MMPK is now opened up by runtime. I can zoom in. We see all the feature details. We got the base maps. We can navigate around. It's all drawn directly on the device. So let's take a look at the code required to open that. It's really very simple. When iOS called in from Dropbox to say I've got this URL, this file at this URL, here's that URL. I go ahead, I create a mobile map package from that URL. I load that mobile map package to understand what's contained within it in terms of the maps. And I get the first map out of it, and I just apply it to the app's map view. That's all it takes to display that map from the mobile map package in the map view on the iPad and make it fully interactive.
Thanks, Nick. Nice demonstration there. You can get an idea of kind of how fairly straightforward it is working with these packages. So when you're displaying a mobile map package or scene package, Nick kind of showed you this code already. It's as simple as you create a mobile map package, instantiated class, passing in the path, you call load. Now you've got to wait because that's an asynchronous operation, but once it's loaded, you can then bind the map view's map to be maybe the first map in the package. The mobile scene package is exactly the same as a map package. You open up the package, you load it, you then bind it to the scene. So let's take a look at the occasionally connected workflow. So this is where you're taking a web map offline. So occasionally connected, you author a map inside of ArcGIS Online or ArcGIS Enterprise. Once you've authored your map, by default it's not enabled to go offline. So you've got to go in and you've got to enable the offline mode. And if you're supporting editing, you've got to enable editing. By default, it's a read-only map. Once that's enabled, you can then have a runtime client download a portion of that map into a mobile map package on the device. And there's two ways that we can work with these web maps when we take them offline. We can work with them in a pre-planned workflow where the author, or if you like the server administrator, determines which areas can be taken offline. Or you can work on an on-demand workflow when the user who's going offline gets to choose the area that they would like. The first, pre-planned, is less flexible, but it is extremely scalable, because if the system administrator defines 5 areas, the server at definition time will create the packages, and the packages just sit and wait for users to come and take them offline. With the on-demand use case, the server does all the work when the user in the field requests the map package. So you can imagine if you have 100 workers or 1,000 workers, say, going offline at 9 o'clock in the morning, your server is going to be very busy at 9 o'clock in the morning. Whereas in a pre-planned, the packages could all be created overnight and they're just sitting there waiting to be downloaded from the server. It scales extremely well. So the data types that you can take offline: vector tiles, raster tiles, features, tables, and feature collections. Here's a screenshot of the settings page for web maps where you enable offline mode. And then when you've enabled offline mode, there's some more settings that you can control to be to further control the offline mode. You can see the allow this layer to be downloaded and used in an offline map, or when it comes to feature services, enable editing, etc. These settings are covered in a lot more detail in the third session because they kind of support more advanced workflows, and we'll cover these in the third session in a lot of detail. With the pre-planned workflow, you have a number of areas. It could just be one area. It could be many more areas than that. But that area is a portal item. It's called a map area portal item. And the map area references a number of other portal items, tile packages, vector tile packages, geodatabases, etc. That's how it's implemented on the back end. But from an API perspective, all that you're working with are map areas, and the API takes care of retrieving all the individual components and rebuilding the map package on the client for you. Here's an example of a second area with its own set of portal items. So how does this work? Well, the portal, on the portal, the author of the map creates the map and then defines the map areas. Within the runtime application, the user gets to choose from the available map areas. So the portal has generated these map packages. It can do it on a one-off basis, or you can do it on a regular basis. Maybe every night during the night when you know nobody is stressing your servers, that's when they can be creating all of the mobile map packages. When the user wants to go offline, they request a map area and they download that map area and they can start working with it. At any time, the user can request the map area. And when they request that map area, if there's a newer version available, it will download the newer version. If there's no newer version available, there won't be anything to do. And you can see this happening here where the map package gets downloaded numerous times onto the device. So let's take a look to another demonstration from Nick, where Nick goes through the process of authoring and using pre-planned map areas.
So I want to take a quick look at a couple of aspects of working with the pre-planned workflow. Here we are looking at the familiar web map again, and I'm going to jump into its description page. So we can go into the settings here, take a look at offline, and you can see, okay, we've got offline mode enabled again as before. We can see there are 5 map areas defined. So let's take a look at what that means. We'll click this button, up pops the Map Manage Areas interface. I'm just going to zoom in a little bit here so you can see, okay, we've got that same context. Here's the same data, it just happened to be out of scale range at that point. But we've got these 5 areas we've already defined. We can hover over them. We can take a look at one of them. Let's take a look at this Columbia Estates area. See there's some little hints and tips here which we can dismiss. We've got some information about this area. How often does it update and when? When's the next update scheduled? So as data is changed in the map area, ArGIS Online or Enterprise will go ahead and repackage that on this interval. We could edit this, delete it. Let's go ahead and create a new area. We'll do that and draw an area right up here. Let's call this Windscape Villages. Say how much detail we want on the maps. Now we've got a vector tile based map here, so we can zoom all the way in without worrying about generating too many tiles necessarily. Every week? Sure, every week. Well, let's do every day again at 5 a.m. And we'll save this. So now it's created that additional area for us. It's busy packaging it up initially. It'll do that the first time you create it. It's going to create that initial package, and then it'll revert back to the schedule. So let's look at that running on an iPad. Here I've got pre-planned application. It's pointing at that web map. You can see it's already picked up that Windscape Villages option. Now I'm not going to load that because it's still packaging right now. We can go ahead and use one of the other ones, like Columbia Estates. We'll tap on that, download it. It comes down over the wire really quickly, and we end up with this map, this fully interactive map with those vector tile based maps sitting behind our operational data. And as we've talked about, we can edit this, we can synchronize this back. But let's take a look at what code was involved there. So if I switch over to Xcode, first thing to think about is connecting to that map. So as we saw with the on-demand, it's pretty straightforward. It's very much like just showing the map in the display. In this case, we're not even going to bother putting that map into a map view. We're just going to create an offline map task based off that map, just as before. Now, when we display that user interface to list out the areas, here's what happens. I'm passing in the offline map task, and I'm just calling get pre-planned areas. When I've got them back, I've got an array that I'm holding onto of areas, and I just set it to the results that I got back from calling get pre-planned map areas up here. That triggers a user interface update. We're not going to look at in this bit of code. The key bit really is when someone picks one of those areas, what happens. So let's take a look here. Here we've got an area that was selected from that user interface that came out of this array of areas up here. We've got that same offline map task again, and we've figured out a location that we want to download that to on the device. We have control over that, so you as a developer can know where these things are being downloaded to. Using that offline map task, we call download pre-planned offline map job and get a job back. Now, with the on-demand workflow, we specified a few things. Here we just specify the area and that download directory. We could add that observer again to watch the progress and keep the status bar updated. And then we just kick off the job. We call start. We get this status handler that gets updated whenever there's a new message to display or the job status has changed. And then we have a completion handler, which is called just once at the end when all the data has been downloaded and it's ready to open. So here we've got a result. We can set that result. And then what we do is we hide ourselves and show the map view. So we've got this result from the completion handler stored away. And very simply, back here in the map view, once we've hidden all the user interface and returned to the map view, we've got that ArGIS download pre-planned offline map result. That's this thing up here. And we just say result.offline map, get that, and associate it, show it in the map view. Make the map views map that offline map we got back. And that's all it took to list the areas, download a specific area, and display the map representing that area in the runtime.
Great, thanks, Nick. I think you saw from the demonstration there how straightforward it was when Nick was working with the map. And the API was taking care of all of the individual requests required to take the contents of that map offline. So with the pre-planned workflow, the code for it, you create your offline map task, passing in the web map. You load it, wait for it to load. You can then ask the offline map task for its pre-planned map areas. You wait for these to be downloaded to you. That's just the metadata about the areas. Once you've got that, you can take the map offline. Now, the way that tasks, all the tasks in the runtime work, first of all, you've got to create the default parameters. That creates, if you like, it loads up the default parameters for that offline map. And then you can tweak them. We won't go into the details of tweaking them here because they're supporting more advanced scenarios. That's all covered in the third workshop. And then once you've got your map, your job started. Once it's finished, you take the result and you bind the offline map to the map's views map, and you see your offline map. So here's the in a sort of pictorial form exactly what I was talking about. You've got your task. You can tweak the parameters based on the user needs and the workflow needs of your use case. You then start a job, passing in that task, and then once the job's finished, you get a result. And if the job is successful, then you can ask the result for its offline map. So this is how this works. With an on-demand workflow, that was pre-planned, what we've just covered. With on-demand, the author of the map publishes the map, and that's it. That's all that the author has to do, because the end user is going to decide at runtime what they're going to take offline and exactly what parameters they're going to use. What layers are going to, if you like, what layers, LODs are going to come offline, the exact area, and the like. And at the request time, the server creates the package, it gets downloaded onto the mobile device, and once it's on the mobile device, both workflows are really the same. At that point, you can use the package. If you want, you can edit the data contained within the package, and you can synchronize changes back to the server. But it's how you get that map offline that is different between the pre-planned and the on-demand. So with the on-demand workflow, you load your online web map, you choose the area in the scale range, you define the parameters, whether you want to download the base map or not, etc. And then you just download it. So here's another demonstration from Nick about taking a map offline with on-demand workflow.
So let's take a look at the on-demand workflow. The on-demand workflow and the pre-planned workflow, for that matter, both begin with a web map. Whether you author that web map in ArcGIS Online or Enterprise or in Pro and publish it up, the web map is central. So here we have a web map with a few layers in it. We jump over to the settings and take a look at the offline settings and see that there's this Enable Offline Mode checkbox. If that's on, you can take your web map offline as a whole. You may need to make sure that individual layers are also enabled for offline mode, but by and large, you should be good to go. So let's take a look at what taking this web map offline looks like from an iPad. Here we've got that same web map, and I'm going to navigate around. We're currently looking at the online version of it. I'm just going to take a portion of it offline. Now, Runtime is talking to the server at this point, to ArcGIS Online or ArcGIS Enterprise, and kicking off a number of jobs on the server side to generate the components that Runtime needs to be able to use this map offline. Here we're pulling together some base maps and some feature services in the form of offline geodatabases. And we'll pull those down to the device and use them to display the data. Now, in addition, ArcGIS Online and Enterprise will pull together metadata about the map, information about layer visibility scales, pop-up overrides, bookmarks, and so on. And that gets pulled down as well, and all hydrated and used together by the runtime to create a full offline map experience. So it looks like right here, we've got the geodatabase down already. We're just waiting for these vector tiles to finish generating and download. Once that's happened, you see the download happens really quickly, and we have a fully interactive offline map. Now what you'll notice here is that some of the features extend beyond the extent of the base map that we were interested in. That's because by default, the map will get complete features down. We don't clip anything. That's important if you're doing editing. So the offline map task allows us to override settings for specific layers if we need to. So what we could also do is we could get rid of this, and we can pull this down with a larger base map area. So again, this is kicking off a similar kind of process as before. In fact, it's exactly the same process, but the parameters for the base map only have been overridden to get a much larger area. We'll look at that code in a bit and compare the code with the overrides and the code without the overrides. So we can see we've got the geodatabase already. We're just, again, waiting for those vector tiles to be generated. Okay, so now you can see that's the extent of the features that we were interested in. You can see some of them extend way beyond that. Only this time we've managed to get a base map that's larger and can cover the area. So what's happening in code here when we do this? So we begin by opening a web map in the application. We do that a lot like we did for working with an online map. Give it a portal ID, portal, and we create a map from it. Again, we're opening that in the map view, but we're also in this case creating an offline map task based off that online map. Then when we click the download button, we generate an area of interest that we want to get. That was on the iPad, that was shown as the red outline. We take the offline task and we generate a set of default parameters considering that area of interest. Once we get that back, we can just say download the on-demand area using the offline task with those parameters. We can specify a location on the local device where we want to keep that offline map. That kicks off this download on-demand area function here. We're just going to set up some UI for the progress bars. And we're going to create a job. Here we take the offline task again. We say generate an offline map job using those parameters to download to that download location. We're going to hook up some progress bar observation stuff to keep the progress bar up to date. And then we just start the job. Now there's a status handler, and here's where we add all those little messages to show what's happening on the server side. But the key bit here is this completion handler. When that comes back, we get an offline result and we're just going to close that download panel. What we do with the offline result is it ends up in here. We just take that map view that we had, and we take the offline map out of that result. So the result being passed in here is this bit here. We just take the offline map out of there and show it in the map view. That was the first demo where we got the base maps clipped to the area of interest. But if we wanted to override the area of interest a little bit, we can just add a little bit of code here. So in this case, we're going to call an override to this function with a buffer amount, and that's described here. So all we do that's different is we generate offline map parameter overrides given the parameters. So we begin, as before, by generating parameters considering the area of interest using the offline task. And then we say, okay, now we've got those parameters, I'd like to override some of them. So please give me a set of overrides that I can modify. And what that comes back with is a really fine-grained set of parameters that will be used to take that whole map offline. Base map layers, operational layers, and so on. And we can go in and we can tweak any one of those settings that we need to. In this case, we want to tweak the setting for the base map layer. So we look at the online map and we just get the first base map layer in it. And we also calculate a buffered area of interest. So we had that initial area of interest that defines how the features are being clipped. We actually want to buffer by a bit more. So we get an override key by providing the base map. And we say for that override key, we want to update the area of interest to this modified, buffered, larger area of interest. So this bit of code here is just saying for the base map layer, get a larger area. And then we just jump back into the code that we had before. And the only difference is that when we create the job, we use a different generate offline map job call that also accepts these overrides. So we have the default parameters that we had before. We also have the per layer overrides that we've tweaked, and it comes down to the same download location, and everything else is exactly the same. We get the same kind of job back, we hook it up to the UI the same way, we execute it the same way, and when we get the result back, we drop that into the map view exactly the same way. So that was getting a web map offline using its default settings for a given area of interest, and then taking a look at how you override individual settings for the contents of that web map if you need to tweak or change anything.
Thanks, Nick. So let's take a look at that in code. You kind of get an idea for the pattern that we're following. We create an offline map task, we load it, we ask the offline map task to create the default parameters. Once we've got these parameters, we can tweak them if we need to, and then we can call generate offline map job with a job. We start it, we wait for the result, and then if the result was successful, we have an offline map that we can use. So it's very similar as the pre-planned workflow. So when you've got your map offline, what about if things change on the server? How do you update your offline map? So it depends really on how you're getting the map on your device. If you're always connected, then you're always up to date. You just need to reload the map and you're going to get the most up-to-date map. Every time features change on the service, backed by the service, if they're being edited, the next time you pan and zoom the map, you're going to get the changes. In an always disconnected scenario with ArcGIS Pro creating packages, you would recreate the package in Pro and redeploy it to your application. In the occasionally connected mode, you would use the offline map sync task, and you can determine when to update based on the workflows that you're trying to support. Maybe you want to update once a week. Maybe you want to update daily. Maybe you want to update hourly. Maybe you want to update every single time you get a reliable connection. These are all supported with the runtime, and it's about looking at your workflow and then making the appropriate API calls when you need to update. So here we have an example of an offline map that's been, a map that's been created in the cloud. It's in my portal, whether it's enterprise or online. And I've got a connection to the internet, so I can, with pre-planned or on-demand, I can get the map and its corresponding data onto my device. And at that point, I could now go disconnected and be working disconnected from the network. Now, at some point in the future, I get a connection to my network again. Now I can perform a sync. Now, we're specifically talking about read-only workflows here in this first session, so we won't go into the details of if you're syncing with edits, that you've made on your device. But I just want to get the latest changes from the server down to my device. I just call sync and I download the changes. If I'm on a purely read-only scenario, I can optimize that process by using scheduled updates. Scheduled updates allow me to download very small packages of content, which is the changed content from the server, on the server. So to show us this, we've got a final demonstration from Nick on updating an offline map.
So let's take a look at scheduled updates. We'll start with what it takes to configure scheduled updates on your map. So here we have that same map again. It's configured for offline. It has 5 available map areas. We're going to jump in, look at these areas, and take a look at the configuration for one of them. Now, when we create these areas, by default, it'll just package them up afresh every so often according to the schedule, here every week at 1:21 p.m. If we enable scheduled updates, what the runtime will do is it will still generate that package, but it'll also generate a tiny delta package of only the changes to the data that have applied since the last package was updated. You can imagine we could do this every day, and so we'd have a tiny delta representing every day, and a map package sitting there waiting for somebody who hasn't already downloaded it so they can get the current state. So all these things are sitting there on the server, generated by ArGIS Online or ArGIS Enterprise. Let's take a look at what that looks like when it's being downloaded by an application. So here we have an iOS application. We can see here in the middle there's an area that doesn't have any data on it at the moment. I happen to know that when I pull the scheduled updates down for this offline pre-planned map that we have on the device, it'll fill in some data there. So I'm just going to tap on the map to kick that off. Now, the first thing that happens is we find out how large these deltas would be if we wanted to download them. Yes, I do want to apply these. So we go ahead, download them, and apply them very quickly. You notice how fast that was. We didn't pull down the base maps. We didn't pull down the entire package. We only pulled down these 2 deltas that represent the changes that have happened since I got the original map downloaded. And then we apply them in sequence and bring our data up to date. If we look at this in code and see what's happening, it's really straightforward. We take that offline map sync task again, initialize it with our local map, that's the pre-planned map we previously downloaded, and we check for updates. Now, we find out that there's some available, and we can find out how much space they'll take, how large they are to download. So here I just pop up that alert that asks the user if they want to download, and of course I did. And we jump in here, get the default offline map sync parameters, and we just call offline map sync job.start. What this does is it goes ahead, downloads each of those delta packages, applies them in turn, and comes back when it's finished. There's really nothing for us to do. There's one exception to that, though. Under some circumstances, the runtime will decide that it's actually more efficient to download the latest packaged up entire package and replace what's on the device already with that latest version. That can happen under 2 circumstances. The first is if the deltas actually turn out to be larger than the latest package that's sitting there on the server waiting, or if that breadcrumb of deltas from the last time that you downloaded the package to the device to today is broken in some way. By default, the server, ArcGIS Online and ArcGIS Enterprise, will keep 5 days worth of deltas. So if the last time you downloaded a package was, say, 7 days ago, and there are deltas missing in between, Runtime will figure out, well, actually, I can't bring you up to date with the deltas that I can download. I'll just download the latest package. And in that case, we have a flag here on the result that's returned to us that says you actually need to reopen this mobile map package. And in that case, we just close what we had already and we load the new one, and the runtime takes care of everything else.
Thanks, Nick. All right, so let's have a look at that in code using the offline map sync task. You create the offline map sync task, passing in the offline map, you load it, you ask it to create the default parameters because you can control the way that the sync works. Are you doing a one-way sync, a two-way sync, etc.? And you get a job, and then you start it, and then you wait until the sync process has finished. And if there's any issues during the sync process, you would get that in the result of the job. So that's how you work with offline and online maps in a read-only way. Let's have a look at the licensing required to do this work. Well, everything that we've talked about today is supported under the Lite license, viewing maps and scenes and layers from the platform with simple routing and place finding. That's viewing content that's been created inside of packages with Pro. That's viewing online connected web maps. Also the disconnected web map scenarios that we looked at in the pre-planned and on demand. They're all supported as long as it's a read-only workflow in Lite. And Lite licenses are zero royalty, so there's no cost to them. Basic licensing kicks in when you start to edit content, and that's going to be talked about more in the second second workshop, which will be coming up next, which is all about editing your data online and offline. So in summary, think about connectivity when you're designing your application. Don't build your application and then think about connectivity as an afterthought. Think about it from the start. And you're really thinking on three ways. Are connected, always disconnected, occasionally connected. And design your map and the layers to reflect your update strategy. So think about how you're going to update your maps when they're already on devices. Is it going to be a push of a package onto a device, which is perfectly fine if the data doesn't change very often? This is often done with base maps, for instance, that update maybe once every quarter or once every 6 months. But for data that's changing dynamically on the server, and you always want your field crews to have the most up-to-date map to use, even though they're not editing the data, then that's probably not the best way to do it. It's probably better using a pre-planned or an on-demand workflow, and you could even factor in the scheduled updates to automate that on the back end. So with that, we've come to the end of the presentation. Thank you for spending the last 50 minutes with me and Nick, and we hope you found this informative.